Hello students, today we will discuss about recursion, method recursion. Okay, so the topic is method recursion. Method recursion. What is method recursion? Any method which calls itself is called as a recursive method. Any method which calls itself is called as a recursive method. Is called as a recursive method. Okay. For example, if there is a method public, static, void, m1, and if this method is calling itself, then this is called as method recursion. This is called as method recursion. Method recursion. Why? Because the name of the method is m1. So this is the definition of m1. Okay, here we have defined the method m1 with its head part and body part. And within the body part of m1, we are calling it. Yes or no? So m1 method is calling itself. So this can be called as a method recursion. Clear? Now, what is the use of method recursion? What is the use of method recursion? A recursive method solves a problem. Use of a recursive method. What is the use of a recursive method? A recursive method solves a problem. A recursive method solves a problem by calling a copy of itself. By calling a copy of itself to work on a smaller problem. To work on a smaller problem of the same kind. Okay. So what is the use of a recursive method? If we have a big problem, I will give you the example. Don't worry. Okay. As of now, just listen. A recursive method solves a bigger problem by calling a copy of itself to work on a smaller problem of the same kind. For example, if we have to add the first 10 natural numbers or first 5 natural numbers, 1 plus 2 plus 3 plus 4 plus 5, then we can use method recursion in order to perform the same task. Okay, I will show you how to do this. But what is the condition? Note, while solving any problem, through method recursion, we must know the condition when it will get terminated. It will get terminated. Okay. If we do not find the condition when it will get terminated, we will get runtime error, saying stack overflow error. So it is very, very important for us to know the condition when we have to stop the method execution in the process of method recursion. I will tell you, don't worry. Suppose example, public class method recursion demo. MR demo means method recursion demo. Let me define one method, public static int, or let me take void. Okay, public static void m1, and let me call the same method from within the body of same method. So here we will get runtime error. Okay, runtime error. We will get runtime error. We will get runtime error. What? Stack overflow error. Stack overflow error. Okay, stack overflow error. This will be the error. Runtime error. Clear? Let me show it to you. See. Control A, backspace, public, public class method recursion demo. Public, public, static, static, void, void, m1 method. And let me call the same method from within the body of same method. Okay. Control K, no syntax error. We won't be getting any compile time error, but we will get runtime exception or runtime error saying stack overflow error. See. Let me call this method M1 method only. See. Stack overflow error. What is the error? Stack overflow error. Now, why this error is coming? The question arises, why this error is coming? Why this error is coming? See, always remember, whenever we call a method, okay, whenever we call a method at the stack memory area, its frame gets created. Okay, let me tell you. See. Listen. For example, if there is a class, public class demo, okay, then there is a method public static void m1. Okay. Okay, let me write main method. Public static void main, capital string, string array space args. Okay. So from within the main method, I will call which method? M1 method. Okay, M1 method. Then let me define public static void M1 method. Now from within the M1 method, I will call M2 method. Okay. Now let me write public static void M2 method. Now from within the M2 method, I will call M3 method. Now let me define public static void M3 method. Okay. Now assume there is some coding within the M3 method. Now this is the block of class. This is the block of main method. This is the block of M1 method. This is the block of M2 method, and this is the block of M3 method. Now what happens internally at the stack memory area? At the stack memory area, what happens? So it is like this. Okay, stack. So first of all, we are calling the main method. Okay, we are calling the main method. So the frame of main method gets created. The frame of main method gets created. Okay, the frame of main methods, main method gets created. Then from within the main method, we are calling the M1 method. We are calling the M1 method. So what happens now? The execution of M1 method starts. So the frame of M1 method also gets created. Okay, M1 methods frame. Now from within the M1 method, we are calling M2 method. So the control goes to the M2 method. Now the execution of M2 method starts. Now the moment the execution of M2 method starts, the frame of M2 method gets created at the stack memory area. At the stack memory area. Now from within the body of M2 method, we are calling M3 method. So the control is going to the M3 method. Now the execution of M3 method starts. Now the moment execution of M3 method starts, the frame of M3 method gets created at the stack memory area. So M3 method, okay, the frame of M3 method gets created at the stack memory area. So when the execution of M3 method is finished, this memory is released. This memory is released. Okay. Now when the control goes back to M2 method, and when the execution of M2 method is finished, then this memory in the stack memory area is released. Now when the control moves to the M1 method, and when the execution of M1 method ends, the memory space allocated by M1 method at the stack memory area, this memory is released. Now when the control goes back to the main method, and when the execution of main method ends, the space occupied by the frame of main method is released. Okay, this memory space occupied by the main method is released. Okay, clear now? So first of all, main method frame got created. Then second, M1 methods frame got created. Third, M2 methods frame got created. And fourth, M3 methods frame got created. Clear? Now what is happening here? See, what is happening here? Assume stack memory area. This is stack memory area. Okay, stack memory area. Assume this is the memory space, total memory space of stack memory area. Now we are calling which method? We are calling the M1 method. So the moment execution of M1 method starts, what happens? The frame of M1 method gets created at the stack memory area. Okay. Now from within the body of M1 method, we are calling the same method. We are calling the same method. So again, the same method's frame gets created at the stack memory area. Now when the control goes to the M1 method's body, once again within the body, M1 method is invoked. So once again, the control goes to the M1 method. Again, this stack memory area here, one more frame of M1 method gets created. Now when the control goes to the body of M1 method again, now again within the body of M1 method, there is a call of M1 method once again. So once again, it is getting called. So what is happening? Once again, M1 method's frame is getting created at the stack memory area. And a time comes when the stack memory area gets filled. Okay. And thus we are getting the error stack overflow error. मतलब stack memory में और जगह खाली है ही नहीं. Stack overflow हो गया. Clear ना? So what I told, we can use method recursion. Okay, method recursion can be used, but we should know the condition when it will get terminated. Method recursion हम यूज कर सकते हैं प्रॉब्लम्स को सॉल्व करने के लिए, लेकिन हमें पता होना चाहिए वो कंडीशन, जिस कंडीशन पे जा करके वो रिकर्सिव प्रोसेस जो चल रहा होगा वो एंड होना चाहिए, टर्मिनेट होना चाहिए. Clear, na? Let me give you an example. Okay. Now see, if the question is write a Java program to calculate and display the sum of first n natural numbers. Sum of first n natural numbers. Sum of first n natural numbers. Okay. If n is equal to 5, then sum is equal to 1 plus 2 plus 3 plus 4 plus 5. That is equal to 5 plus 4, 9, 10, 11, 12, 13, 14, 15. So the output should be 15. Okay. Use method recursion. Use method recursion technique. Use method recursion technique. Okay. Use method recursion technique. Now what is the bigger problem? See. Suppose we have n. N is equal to 5. Okay. So 5, if n is 5, that means the task is, what is the task? The task is to calculate 5 plus 4 plus 3 plus 2 plus 1. Yes or no? Now, can I write 5 plus, that is, can I write 5 plus sum of first 4 natural numbers? Sum of first 4 natural numbers. Okay. Now this 4 can be written as 5 plus sum of first 5 minus 1 natural numbers. Yes or no? Okay. Now, suppose 5 plus 4 plus 3 plus 2 plus 1. Now this 4, can I consider it as sum of first 3 natural numbers? Sum of first 3 natural numbers. Now first 3 means 4 minus 1. Now if I write 5 plus 4 plus 3 plus 2 plus 1. So this 2 plus 1, okay, this 2 plus 1, can I write it as sum of first 2 natural numbers? Sum of first 2 natural numbers. Now when I say first 2, it means 3 minus 1. Okay. Now when I write 5 plus 4 plus 3 plus 2 plus 1, only 1. So 1 means sum of first 1 natural number. Sum of first natural number. Sum of first natural number. So first 1 natural number. Okay, first 1 natural number. This 1, how it can be produced? By writing 2 minus 1. Clear? Now can I say that we are doing what? N plus find. Suppose, let me give the name of the method get sum. Okay, get sum. Get sum n minus 1. Now within the body of the method, I will call the method once again by writing get sum n minus 1. Let me show it to you. Don't worry. I will explain. public static int get sum. Okay, int n. N means first n natural numbers. The user will pass the value of n if he or she wants to add first n natural numbers. Okay. Now, if, what is the base case? The smallest version of the problem. If n is equal to 1. If n is equal to 1, so we have to return 1. Yes or no? I think if the user is giving 1, so sum of first one natural number will be 1. None. So if n is equal to 1, we have to return 1. So this is the base case, or we can say terminating case. This is the base case, or we can say terminating case. Or we can say terminating case. So this is the condition in which the recursion process will get terminated. Clear, na? Now else, if n is not equal to 1, so what I will do, I will return what? N plus, and then I will call the same method. Get sum of what? N minus 1. Sir, why? I have already explained here. See, sum of first 5 natural number means 5 plus sum of first 4 natural numbers. Now sum of first 4 natural numbers means 4 plus sum of 3 natural numbers. Now sum of 3 natural number means 3 plus sum of first 2 natural numbers. Now sum of 2 natural number means 2 plus sum of first natural number. Yes or no? So 5 plus get sum n minus 1. Get sum n minus 1. So this is the recursion case. This is called as the recursion case. Okay, return n plus get sum of n minus 1. So this is how it can be defined. See, let me show it to you. So name of the class, public class, natural numbers ADDER, natural numbers adder. Okay, public static void main capital STR ing string array space args import import java dot util dot sca and an er scanner. Okay, here let me create the object of scanner sca and an er scanner scn equals to new scanner. Watch the video completely, okay, then only you will get to know. System dot in, system dot out dot println enter the limit till which you want the sum of natural numbers. Okay, int n is equal to scanner object dot next int. Means the user wants to get the sum of first n natural numbers. So here I will write int sum is equal to, I will call the get sum method. I will call the get sum method by passing n. Okay, and here I will display system dot out dot println, system dot out dot println what? Sum of first concatenation sign n natural numbers is equal to concatenation sign sum. Concatenation sign sum. Okay. Public public static static int get sum int n. Okay. Now listen. So what I have done, by the help of scanner object, I have asked the user to enter the value of n. I means the first n for to find the sum of first n natural numbers. The user has to give the value for n. Now I have passed the value of n to the method getSum, and this getSum method is expected to return the sum of first n natural numbers, which will be stored in variable sum. Okay, and after getting the sum value, I have printed. Now it is the time for me to decide how can I define this getSum method recursively. Here I need to apply the concept of method recursion, where the method getSum will call itself, and will produce the end result and will return the end result. How? So think about the base case, the smallest version of the bigger problem. So what could be the smallest version of the bigger problem? The value of n could be 1, because the first natural number is 1. So we will write if n is equal to 1, okay, then we have to return 1. Now first one natural number, sum of first one natural number is 1 itself. So if n is equal to 1, we have to return 1. Now if n is not equal to 1, then we have to call the same method by writing return what? N plus getSum. N plus getSum what? N minus 1. N minus 1. Control K, no syntax error. Now let me execute this program. Suppose 5. See, the sum of first 5 natural numbers is equal to 15. Okay, is equal to 15. Clear, na? Now let me give the value 10 to this. 10. See, the sum of first 10 natural numbers is equal to 55. Clear, na? Okay. If I give 2, sum of first 2 natural numbers is equal to, just 1 minute. Yes, if I give 2, so sum of first 2 natural numbers is equal to 1 plus 2, that is equal to 3. 1 plus 2, that is equal to 3. Okay. Now let me show you how this method is working. Okay, how this method is working. See, very, very interesting. Listen. Public static int getSum. Okay, int n. If n is equal to 1, we are returning 1. Okay, else we are returning what? N plus getSum what? N minus 1. Okay, suppose the value of n is, suppose the value of n is 3. Okay, the value of n is 3. Now 3 is equal to 1? No. So here the method will not return 1. So else part, return n plus getSum. What is n? It is 3 plus getSum n minus 1. So here n minus 1 means 3 minus 1, that is equal to 2. Now assume, see this line, See the second point. A recursive method solves a problem by calling a copy of itself to work on a smaller problem of the same kind. Copy of itself. Now let me draw the copy of the same method. Let me write the copy of the same method. Public, just 1 minute. Listen. Public static int get sum. Okay. Int n. If n is equal to 1, we have to return 1. This is the base case. Else, in else part, what we are doing? We are returning n plus and calling the same method. Get sum of n minus 1. Now listen. Now here, when you are passing n minus 1, at that particular time, the value of n was 3. So 3 minus 1, 2. So 2 is getting initialized to this parameter. Again, yes or no? Okay, now here n is equal to 2. Okay, 2 is equal to 1? No. If no, the method will not return 1. Then what it will do? It will return n. What is n? N is 2. 2 plus get sum of n minus 1. What is n minus 1? It is 2 minus 1, that is equal to 1. It means once again the method will get invoked. Once again the method will get invoked. Listen. Public static int get sum. Okay. Int n. Same thing. Copy of the same method. N is equal to 1. Return 1. Return 1. Else, in else part, we are returning what? N plus get sum of n minus 1. Get sum of n minus 1. Now listen. Now, in the second part, while invoking the get sum method, we have passed, automatically the value is passed. What is the value? 1 is passed. Okay. So the value 1 got received by this parameter n once again. Now, if n is equal to 1, yes, n is equal to 1, return 1. Return 1. Now listen, very, very interesting. So this method returns 1 where? Here. At this part. At this part, the value 1 is returned. Okay. Now return this part. So 2 plus 1, that is equal to 3. Okay. So this method returns 3 where? Here. Okay. So what is returned? 3 is returned. Now here what is returned? Here what is written? 3 plus 3, that is equal to 6. So this method returns the value 6 to its caller. See, some first n natural numbers, 1 plus 2 plus 3 is equal to 6 only. Yes or no? Okay. So this is how recursive methods work. So if a method calls itself, the copy gets created and the copies perform to provide solution to the smaller version of the problem. Clear, na? Okay. Similarly, you can perform the dry run using larger values for n. I hope you got the point. Clear, na? So practice this program. It is very, very important. Bye-bye. Take care. Huh?